Hello! How is everyone doing? Yes, send. There we go. Okay. So, we're back with the Blacksmith game. And last time, we finished the part where we can move vertices now. We are able to move the vertices to where we can move them into any arbitrary shape and it will not break. Okay, well it kinda breaks sometimes. It breaks when you're going in. But if you're just trying to go out, everything's fine. But sometimes you get some weird intersections. What do you mean back so soon? Yeah, I had a vacation. I went to Florida, got to see some family. One of them is my uncle, who's also developing video games, and it's very fun. We got to talk a lot about our different game projects and what we're doing. Yes, it is. Thank you. Dream avatars. Thank you. And Stream Elements is broken. What? I did have a good trip. Thank you, Time. I couldn't see your name because it's black for some reason. Oh goodness, everything's opening. Stream Elements, connect. Perfect. Wait. There's a little bit of a problem. The thing that I use to check that perfect stealth mode. Look, you can barely see it. That's funny. Okay. I need to, I think, reset streamer bot real quick. Something deeply wrong with this. Streamer bot. Streamer bot is fantastic, by the way. StreamerBot is free. You can make a bunch of edits to it and everything works. Yeah, we are not at 0 followers, but for some reason it really thinks we are. I don't know what happened though. How did this happen? Give me a moment. Yeah, how's everything been going while I was gone? You guys didn't burn the server down? Nothing horrible happened? Wait one moment. Oh, shucks. Everyone unfollowed? Yeah, it happens, man. Okay, wait. Okay, we're going to my webcam. Wait, real quick. I have to do some funny things in Twitch in order to make this work. Whoops. Whoopsie daisies. Going to test alert. Where are you? Okay, now it should work. We're back. Okay, everything works. Goodness gracious. Yeah, everything broke. There we go. That was weird. Yeah, we can edit. We can move these vertices around. Mostly. If we move it too far in, then we have problems to where we get an intersection and then it can't move anymore. Which is really weird, and that's not right. I don't exactly know what's happening here. Okay, the intersections are a problem, but it doesn't break the mesh anymore. Which was the main worry previously. Well, yeah, the mesh breaking was the main worry previously. Oh my goodness. Oh, okay, there we go. Now we're back. Can you guys see into the void? Just a little bit, just a crack into the void. There we go. Goodness gracious. Yeah, so we need to figure out how to stop that from happening. And then also how to test the shape. Because what I want to happen is as the player gets closer to, like, let's say we have like a pickaxe shape. I want the player to, like, try to approximate that. And then they get a certain amount of points, and, like, that's how bad they did or how good they did. So, like, this would be probably not fantastic, but then they could go to the grinding stage and then fix it up. But we need to be able to move the vertices in, which we kind of can't do right now. And, yeah, we get these intersection problems. Which is intended with the code that we have implemented, but then just stops working. You can push them internally. So if I were to do, like, this and push all the vertices out of the way... Wait. This is the problem. Okay, wait, let me go to the mesh texture. Yes. What? What are you doing, man? Okay, wait. Let me drag that into these. What does this look like? Oops. 1 by 1. There's a way to make this tile properly. I have no idea how to do it, though. The channel points awards? I disabled them temporarily. Because I want to do a revamp of basically everything. What is happening here? Why is this not right? Oh, I know why that's not right. Oops. I need to go back and... Ugh. Okay, I have to rewrite some code real quick. Where are you? Anvil... It was mesh testing, right? Where did I put this? Oh, in its own mesh testing. Alright. You wanna make me do exercise? It will be back, maybe. We'll see. Alright. Okay. I need this. That was the problem. I don't think this is ever used again. No. Okay, that should fix it. I think. Now we should... Yes. So yeah, the problem is this is like reaching a line and then it's trying to intersect. Because we're moving these vertices around and stretching them. Which causes some problems. So... we could either move the vertices, like whenever there's an intersection, like this... wait. Like that? Then we move both of these vertices in the direction that this would move, checking for errors. Or... we could do what I thought of previously, which is really cursed. I'll be honest, it's pretty jank. To where we have, like... we have all of the vertices on the sides here. Like a bunch of different points, and then we just have one in the middle. And we keep redrawing this mesh to make sure that this is always in the center of mass, or we always put this in the center of mass. Because that way, it will never be a problem. And we just have to calculate that. That's the real problem. To where, like, if it was like this, then it would need to be here. But that would lead to problems with something like this, to where we would need multiple. We would need one here, and one here in order to stop that from happening. You're just gonna say fiddlesticks now? That works. Okay. And then, yeah, we could have like one here, one here, one here. And we could have all of the vertices connecting to these. That's really jank. But what we have right now isn't working as we need it to. It works like a lot. It works a lot better than what we had previously because the mesh isn't breaking and the mesh can never break, which is really good. But now we have the problem of the mesh isn't deforming how we need it to. I feel like this is honestly going to be one of the hardest problems in the entire game for me to solve, is to figure out how to make this mesh deform properly. I don't know of anyone else that has done this. Anything remotely like this. Because if we look at the code, the line cross code, this is cursed. Like, deeply cursed. But we are getting the vector that it's crossing. So, like, this is the first point, the second point, third point, the fourth point, and then the collision point. Wait, are we even getting... Okay, we are. Okay. Could propagate the push on the intersection, as you mentioned, and try to push the length. Or push it the length that the previous vertex was unable to move. That's definitely... We can definitely try that, but then we're gonna have to check for everything again. I need to actually read this again and make sure that I understand what the hell's going on. Because this is a... Ugh. Okay, this is... Line A point, line B point. Wait, what? Oh. I don't think I ever... Oh no, I just moved it directly into here. This is the correct one. That was my test script. So they could then intersect something new. Yeah, it is scarily recursive, and that's the problem, is because because then I'm gonna have to check literally everything. It's gonna be... Because what's really nice about this is we are checking everything, but we're only moving everything once. Like, nothing is getting moved multiple times. Unless it intersects, which then we're just moving it to that intersection point. I don't think that there's ever a... I'm trying to think, is there ever a point to where it would keep moving so much? No, it'd always move away. So it should only move a few times at most. It wouldn't be that inefficient. It doesn't even matter. I just need to be able to read this code. Okay, so... Oh, dude, this is a disaster. This is why I should have named everything properly. But here we are. Oh, goodness gracious. Okay. Okay, so S1 and S2. This is... A1 minus 8. Okay, so this is just the difference between these two vectors. Or the distance. This just gets the distance between these. Which is really just the difference. So if we open up Yeal MS Paint and just kind of like move it to the side a little bit so that I can read the code while we're doing it. So it's basically just doing this. we have two vectors. We have 2 points, sorry. We have point A1 and point A2. And then we're just subtracting these points. So we're getting the the distance between them. Should be the distance. But in reality, we just have 2 vectors. Which I'm gonna call, yeah, A1, A2, B1, and B2 are points. S1, A2 are the direction vectors from the point A1 to B1, I think. This is A2 minus A1, which is pointing that way? Other way. Okay, yeah. It's way easier to visualize this as matrices. Okay, because it is, or not matrices, vectors. These are just vectors. They're vectors. So this is a vector. So what we're doing is we're doing A1 or A2 minus A1. So if, yeah, so I'm just gonna do like a really easy example where we're just gonna have like a coordinate grid that A2 is pointed like that. And then that's pointed like that. So the vector should be, is going to be 1, 1, minus 0, what? Yeah, minus 1, negative 1. Yeah, that's right. So then we're going to get a vector that is 0, 2, which is up here like that, which is correct, because if we think about it like we're adding the inverse of this, which would be pointing that way, to this, then it is just that. Okay. So yeah, we're getting the vector basically pointing from point A1 to A2, I think? Because, yeah, that's the difference between these. This is A1, A2. Yeah, so it's pointing from A1 to A2. Goodness gracious. Okay, so we have a vector pointing from A1 to A2. Then we have a vector pointing from B1 to B2. That's what S1 and S2 are. This is S1. This is S2. We're then getting the dot product, I think, of this. Correct? We're getting this is the... Is this the dot product? The cross product. This is the cross product. I need to look up the algorithm for cross product again. Cross product formula. Okay, here's the cross product formula. Ah. Okay. 2D. Cross products, my beloved. Yeah, this is too much math symbol for my brain right now. It's different for vector 2 because it's only a scalar. Okay. Okay, this is A1. This is B1 to A1, the vector from B1 to A1, times the scalar negative the different. Okay, what the hell is this algorithm, man? Where is the original? I need to read the original thing again. I'm going into my history, the deep dark depths. History. It was on Stack Overflow, I think. Okay, we're gonna go deep in the depths. I think it was on Stack Overflow. Was it this? It was this. Okay, I found it. I think it's gonna be way easier to read this than try to figure out what's going on in the code. There's a nice approach to this. Okay, define the two-dimensional vector cross product. V cross product W to be Vx times Wy minus Vy times Wx. Okay. Times Wx. Okay. That is not what that does. Okay. Okay. The following function, the in C, both detects the line intersects between the section and its point, is based on the algorithm in Andrei Maloth's Tricks of Windows Game Programming Gurus. Okay. It's not dissimilar to some algorithms in other answers. Okay. Who is this person? Yes, Gareth. Okay. Gareth. Lamont then uses Cramer's rule, don't ask me, to solve the equations themselves. What? Okay, so... Brother. How the heck did we do this? Okay. When we get in the intersection, what does it print? Okay, this is actual gibberish. This is two vectors. It's because A1 is a vector. What? This isn't the collision point at all, actually. Okay. This prints A1, and then this. Why? Okay. A1 is the first point. And then this is... Okay, so this is the current point we're moving. This is where it's going. This is the line between these. So what I need to do is just, if there is one, return t. Okay, so if it does not equal -1, then I need to... I just break? Okay, so we need to, instead of just breaking, we need to change these. Plus equals velocity. Plus equals velocity. Oh no. Oh no. Okay. Yeah. Okay. Here's what we need to do. This is gonna be really weird. Tried both S and T last time, don't remember which one. It was T. T was the right one. It's gonna get really weird, man. Okay, so just bear with me. This is going to have to be recursive. Don't like that, but we're going to. Okay, here's what we're gonna do. I really hope this doesn't crash my computer. We're going to set, first, the vertex velocities of this equal to velocity. To velocity. And then we are going to call update vertex with this. I think you would just add the 1 minus t times velocity, so it can get the velocity that wasn't applied to the first vertex. Yeah, no, so this is the velocity that wasn't applied to the first vertex. The only problem is, when I move that vertex, I need to then check that it is not crossing other lines. So I need to do it. Remember when you were talking about how scarily recursive this is? Yeah. Yeah, no, you're just right. What the heck is second index? Okay. This is hopefully okay. We're going to see if this instantly crashes everything, and if it does... Oops. If it doesn't, that's amazing. That's awesome. Okay, let's shoot. Okay, the second it crosses... Okay, wait. It's not instantly crashing anything, actually. It seems to be fine, it's just not working like, properly. Ooh, weird. Yeah, it seems to be moving, like, way slow. Yeah, I don't think it's actually changing anything. What if I do plus equals? Oh, I think that... What? Is this a vector 2? This is a vector 3. Okay. Why is this a vector 3? If I make this a vector 2, do I get errors other places? I do. Okay. Oh yeah, no, this has to be a vector 3. That means I can just do vector 2. That's fine. Okay, I can just cast it. That's all good. Okay, this may invariably snap my code. Okay, this looks really weird. What if we apply the white material? Does this kind of look like it? Ooh, what is that problem? Oh yeah, I need to... Oopsie daisies. And now I need to swap that over. Yeah, this doesn't work how I would expect it to. Because it needs to start caving in. To where, like, it's just kind of moving, but I would expect it to start caving in there if I was hitting there. Oh, goodness, what have I done? Okay. Okay. Do I need to... Try to stop the initial vertex moving in front of the intersection instead of exactly on it? Try to stop the initial vertex moving just in front of the vertex. Okay, I can do that. Where is that? Okay, times 0.9 F. 0.9? That works. Let's go like 0.3, 0.5. Okay, what does this do? What? Okay. Okay, I need the figure. I'm gonna go back. We're going to uncomment this code. It worked, but I don't know why it worked, and it kind of... Okay, wait. What? How did that work? We need to do some testing real quick. Oh, okay, wait, what? Oh no. Wait, what? Wait, I don't even know if this is breaking. I don't think it is. No, it doesn't work quite. No, now it's actually just breaking the mesh again. Not good. Okay. Hmm. The mesh is breaking. That's what's happening. Wait. Why is the mesh breaking? That actually doesn't make any sense, because we're pulling back on the scalar. What? Oh, I think it's if the scalar's negative, then... Oh, wait. This needs to be not that. This needs to be, I think that might work. I'm gonna uncomment this. Okay. Oh, that's not good. Oh yeah, no, that's like really not good. Man. I feel like this is a problem that is possible to solve. It has to be. It has to be. Hmm. We really only need the positions of the outside vertices, right? Like, nothing else matters. Hmm. We might have to just remake the mesh every time. Yeah, but I kinda need to be able to. Which is a problem, a problem to say the very least. Okay. I'm going to do something a little bit wacky and connect all of these lines. Just hear me out. I think I might find something in this. I have a feeling. I'm high on believing. Because I need to find, if I find where all of these cross, every intersection point, then that's where I need a vertice, right? Because what I really need, I need like a vertice for this one, like here. That would reach everything. Whoa, wrong color. Because, like, these can't connect. This is in open space. This isn't inside the shape. So I can just kind of get rid of those. And then remesh the object. Because, again, I need... Like, if I have a point here and here, I think I can do everything in the shape, right? Because, like, right here and right here, I can connect everything. Should be able to connect everything. I connect that, 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 that. Okay, that's fine. That, 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 that. That. And now everything is a triangle. And we can make triangles. It's just figuring out how to do this is really gonna be hard. Yeah, I don't know either. Because I don't think that the path we're going down is going to have a solution for us for concave shapes. Because there are just too many things that we have to account for. Because when we're moving these vertices, like, eventually something's gonna cross. If we're going concave. If it's always convex, nothing will ever cross. I know there are algorithms for checking concaveness of a mesh, but you're not familiar with them? It looks like I need to start finding them. Because if it's convex, no matter what, any convex shape, that would be concave. any convex shape, I only need one center vertice at any point. Literally any concave shape, I only need one. But the second it becomes convex, I need multiple on the inside. Which, my solution originally was just put a bunch of vertices in there and just hope that it works. But that's a really naive solution. Because it clearly isn't working, first of all. Second of all, it was kind of just based off of feeling and not any mathematical rigorousness at all. This is always true. I'm pretty sure. This is also kind of based off of feeling, to be completely honest, but I'm pretty sure, I'm sure about this one, okay? I can't, I feel like that's like a innate rule of concavity that it is, you can always connect to one, right? There's a center point that nothing crosses. How to determine if a shape is convex or concave?
Is this polygon concave or convex? To answer this question, we're going to need to remind ourselves of what it means to say a polygon is concave.
Okay, we're gonna have to do a lot of research, so strap in, alright?
What it means to say a polygon is convex.
Oh, man.
A concave polygon is a polygon with one or more interior angles measuring more than 180 degrees. A convex polygon, on the other hand, is a polygon with all interior angles measuring less than 180 degrees.
Okay.
So to be able to use these definitions of concave and convex polygons, let's also remind ourselves of what an interior angle is. An interior angle is an angle inside a polygon at one of its vertices. So all of these angles inside this polygon are interior angles. We can see that these angles range from 90 degrees up to 140 degrees. Therefore, all of the interior angles of this polygon measure less than 180 degrees, and so this polygon is convex.
Yes. Awesome. Alright, so that is the defining rule. If it's less than 180 degrees, then it is concave or convex. If it is more than 180 degrees, it's concave. Always should be true. Yes, always is true. Okay. That is the mathematical proof. That's how you determine it. That's the reason. Okay. What is a convex polygon? A convex polygon is a polygon that has all its interior angles less than 180. I had to turn music back on. Okay. Regular convex polygons have all sides the same length and all interior angles of the same measure, less than 180 degrees. Convex polygons are not regular, or convex polygons that are not regular are called irregular convex polygons. Sure. Okay. So, given a pentagon, ABCD, all interior angles are equal measure, state whether the polygon is a convex polygon. Okay. If they're all the same, they're all of equal measure, then it will always be. Sure. Okay. It's the area. And the area, okay, calculate the sum, I don't care. Concave. Okay. So, B, C, D, you can create a line between them. that is not cross in the shape. Okay. At least one diagonal lie outside the closed figure. I understand all of this intuitively, but I'm trying to figure out a way to put this into code. Because that's really what we need to do. We need to figure out, is this convex, is this concave, and then what we're going to do about it. For this one, if we put a point right here, then it could go between all of these. Very easily. If it's concave, or it's convex, that's always true. If it's concave, it's not always true. Now, when is it not true? That's what we need to figure out. We can find the angle measure between these. It's going to be some weird math, but... I mean, like... We have points, we know how to find the angle between points. I think we'll live there. Okay. Convex polygon, concave definition, sure. The difference between concave and convex and concave shapes, no dents, sure. That is concave. Bigger angle measures. This could still just have 1 point though. This only is 1 point. Again, that's convex. Will always only need 1 point. This, the line joining any 2 points on a concave shape may or may not lie on it, but 2 points lies completely on it, so it will always. Even if we put a point right here, it will connect with everything. That is a defining rule of convex shapes. Not for concave shapes, though, which is our problem. We need to solve this problem. We need to find how many points we need to be able to do everything, or in order to connect everything. Okay. Okay. Yes. Regular angle 40, sure. Okay. This is concave. Wow. This is convex. Wow. This is what? Yes. Yes. What? Oh. Yes, I'm doing basic math problems. My brain is fried. Okay. Is it less than 180 degrees? No, it is concave. Okay, cool. So yes, it is always true. How can you determine if it is concave? Okay, if a polygon is not convex or non-convex, it is concave. Okay, some diagonals of a concave polygon lie partially or wholly outside the polygon. Okay. Wait a minute. Wait. Not a mesh collider. What do we need? Polygon collider. Polygon collider. What if you make this like 7? Uh-huh. Wait, what the heck? Okay, wait. Size 7. There we go. Points. One, two, three, four, 5. Okay, yes, there were some that are... What? Where are these supposed to lie? Why is it not want to be 5? Okay, we're just gonna make it 5 then? Because this algorithm has already figured it out. Look. Look at it. It's only making quads or triangles. And if it gets too bad, then it just makes another triangle. Interesting. So if we just... Yeah, if we could just steal this generation. Because, again, the second that it's convex, it has to create another triangle. Here's a question. Here's a question. Wait. Okay. Okay, so we currently have... Wait, I want to try something. We have a singular concave angle. One angle higher than 180 degrees. Correct? Okay, now... If I move this... Now we have two concave angles. It only needs one, though. Now we have... Still only two. Now we have three, and there are three lines. Is there ever a point where we need three lines with two concave angles? No, that's not possible. Okay, but the second we get three concave angles, that is possible. So you need at maximum the amount of lines that we're connecting per angle. So if we have, or per concave angle. So we need three here, but we can need two. That's possible. We can do it with two, but you need at maximum ever three. Because yeah, that just breaks. That doesn't work. You can't do that. Very interesting. Yeah, make a Unity util to make shape from points? Wait. Wait! Wait. Okay, there's something... I swear this exists. I think I know exactly what you're talking about. Wait. Sprite shape. Okay, wait. Unlock. This is dealing with splines, though. But it does deal with concavity. Wait, brother. Okay, the second that it gets concave, it gets super weird. What? What? Okay. Okay, it doesn't really like concavity. That's really weird. It's also snapping to the grid, which I don't really like. Okay. Weird. So, this just kind of breaks after a little bit. Is there a way that I can make the line a lot smaller? Why is this just dying? Why does this just break so easily? Bound scale? What? I set that. What is the point of this? What does this even do? If I set this like super high, does it do anything? No? Then what's even the point? Why does it just break so easily? If the angle gets too harsh, it just explodes. Wait, the height. Maybe? Maybe the height being really small will actually save us from this problem. Kind of. kind of saves us from this problem. But he stretched. Wait, what just broke that? Okay, that's actually just, yeah, that makes sense. That broke it. Not automatic, but if we just stretch it. Wait, we might... Okay, no, this needs to be stretched. How did this break so fantastically? Oh, that. This is an interesting route to go down. Okay. Hey, Pio. We're still arguing with, the Anvil minigame, where it doesn't really like us, and we're not too happy with it. I'm trying to explore, like, different options that we have. Whale Time just suggested that there may be a Unity library for creating a mesh like this. So I was like, wait, sprite shape exists. I don't think we can use this, though. Which is really sad. Why does this... Why is this so weird? I don't think the bounce fields matter. You know, this just dies if you go too far, which makes sense. Excuse me? That's a joke, right? Wait. That's a funny meme you got there. That's a... There's no way, right? Like, they wouldn't just, What? What? Okay. No. No. Can we just take a minute and appreciate how absolutely trash this naming scheme is? Unity 6000 .0.0 B11. What? I need to see the engineer that decided this. It's less than 9,000. First of all, disappointing. Second of all, what the hell am I looking at? What's the point? Why are you doing this, Unity? Alright? We need to have a serious sit down and just chit-chat about what the hell is going on with your naming schemes. Why? Why do this? What's the point? What do you gain? Besides everyone being just a little bit more confused. Anyways, what the hell is that naming scheme? Why? Skip 2024? We're now the year 6000? Goodness gracious. Okay. I don't think that this is going to work. But maybe. How to generate a mesh based on outside points. Unity. Shooting mesh given an outline. This is promising. Triangulator. Wait, why? But why? Unity triangulator. Wait, this might actually... What? It's pseudocode, however? Okay, wait. What? This is very interesting, though. Thank you very much for sending me this. Okay, so this is Mark Keel's algorithm. Since the algorithm... Okay, let's look. Without optimization tweaks, Keel's algorithm is actually quite straightforward. A polygon can be decomposed into convex regions by simply eliminating all reflex vertices. Keel's algorithm works by examining every possible way to remove a reflex, or the reflexity of these vertices, and then takes the one that requires the fewest diagonals. So this generates the most efficient shape. That's cool. I don't really care about how geometrically complex the shape is. I want this to be fast, so we can probably edit this. We can definitely... This is an interesting route to go down. Very interesting route to go down. Okay. Since the algorithm tries all possible solutions, it takes the best one. It is always optimal, produces the minimum number of convex regions, or the case without Steiner vertices. So, this is very interesting. There's only one... First, I'm downloading a zip. This is... No, I will not be buying WinRAR. Thank you, though. This could be really bad. Here's to hoping it's not a virus, smiley face. Anchorman's I'm in. No, no! Didn't ask? Okay, here's what we're gonna do. We're gonna open Visual Studio Code. Open folder. Downloads. Wow. Yeah, I trust them. I trust them, smiley face. Okay, yes. Install. Makefile tools. Awesome, thank you. Okay. Let's compile this. Yes. Okay, I'm gonna be honest, I don't actually know how to compile with a makefile. Hopefully that does. Versus dependency? You fool. Why? I told you, I'm in full trust mode, alright? My computer has already been taken over. Yeah, there's an error anyway, I can't compile it, that's fine. Alright. Scalar, don't care. Okay. Where is the code that I need? The point polygon array. My brother in reality. What's the point of making the CPP? This doesn't even have... Okay, this guy didn't actually even write the code. This is useless to me. That was my computer getting taken over. Good, good. I can feel it. I can feel it being taken over. It's not in Polygon, no. He didn't actually finish the code. It was tested on Ubuntu. Okay, good one. Or he just has empty files for some reason. Doesn't matter. Okay, so... What is this? For every vertex j, if I can see j, so that's if there is nothing intersecting these, then Left the polygon, given the vertices. Whoa. Whoa. Okay. This is what I was talking about with adding, like, points in the middle. It's really complicated, though. If there is just a built-in Unity plug-and-play, like, hey, here's the points, here's the mesh, I'm just gonna use that, because this is really... If we can't find anything else, I'm using this. Because it seems that it would work, given what the explanation is. Implementing the explanation could take a long time, though, and if I ever need to optimize things, I might go back to these. Wait, oh, thank you for the suggestion. I'm gonna go back to that if I can't find anything else, but... Oh my goodness. Ah! Oh no. Wait. Okay. This is good though. Wait, why? The Godot devs are coming in just to ruin people. Oh wait, no, he's giving an example. Okay. External library or implementing itself. Okay. Never mind. That'd be just deeply hilarious if he's just like, you should switch to Godot. Here's the explanation in Godot. Good luck. Have fun. That'd be really funny though. Yeah, I know how to do this. Thank you though. Anyways. Huh. The input angle in radians? It might have been in Polygon. I don't think I actually checked that. Wait, let me look. It mightn't be in Polygon. Wait. Hey, this is the CAMC. No, it is in Polygon. Godot has a ton of useful functionality like that for procedural meshes. Really? Looks like it might be. Interesting. Welcome, Darth! I'm back from vacation, and we are fighting the... ye ol' blacksmithing minigame. This guy's using OpenGL, I think, maybe. I don't really know what I'm talking about. Yeah, I can't read this. This is... No, maybe... I think that this is what this is. This can-see function, I think, is the correct thing. Basically, we're gonna... Yeah, that decomp function? Okay. I'm gonna put that on the shelf for a moment, and then I probably will come back to that at some point. That's really interesting, though. Thank you. Yeah, what are you doing for your current project? Tell me everything. Genuinely, though, people putting stuff in the show off your work. I love this so much. I love it so much. Join the Discord if you're not in there already. I love seeing people's work. I feel like seeing other people, it's just free motivation, unironically. Showing off your work, you get feedback, it's free motivation, and then other people see your work and they're like, dang, I want to make something cool. It's a 2.5D old school Zelda-like with 3D physics. 2.5D, so it's top down? So it's like a top down old school Zelda like to where it's a top down like adventure game. And by old school, do you mean the original Zelda, or are we talking like Link to the Past? Like a 2D Zelda game, but in 2.5D with 3D physics. How does that work? 2D visual, 3D physically. Interesting. Pre-3D. Okay. So yeah, so like Link to the Past, A Link Between Worlds, the top-down, like, dungeon crawler adventure games. Yeah, okay. That's really cool. Tell me everything, now. And send screenshots into the Discord. Okay. Why did this guy send sign? The page isn't found! Oh, this is just the worst. Oh, brother. Oh, this is 100 random points. It's still very early, only placeholder programmer art. Do you want to see my art right now? Okay. Wait, save. Bask in its glory. Okay? There is no judgment here for programmer art. Can I not remove this? Let me lock it. Let me lock it! Oh, I guess this is just here now. Whoopsies. Can I actually... You cannot remove this. Because another installed package or feature depends on it. See dependencies. Okay. It's used by 2D. What? Okay. Good one, Unity. Yeah, I'm thinking about switching to Godot for this project. I'm not sold on Unity. My only problem with Godot is that it would severely limit my ability to export to other platforms. I can export to Windows really easily. And I can export to Linux and things like that. Like Mac, Linux, and Windows. But if I wanted to do... Which that covers the Steam Deck, which is really good. But if I wanted to do like Xbox, PlayStation, or Switch, I can't do that. Unless I manually convert the code. I don't know how to do that. I have no idea. I know that Godot is trying to get better about that. It's because it's an open source engine. It kind of just... There's not much that they can do about it, but... You're still not used to Godot script. I feel like... Yeah, it looks a bit weird, but I feel like I would get used to it pretty quick. Another thing I've been considering is using like Game Maker. Game Maker is actually a really good option, but it's hard to do 3D to 2D, which I want to do a 3D to 2D pixel art style, but my uncle uses Game Maker, and he does some really cool stuff in it, so it's very powerful. He showed me it. Okay, what was I on about? Oh yeah. Oh, dude. Matrices, my beloved. Okay, Oh, brother! It's not easy to port in Unity either, extremely expensive for licenses and such. It's expensive for the licenses, yeah. Once you have the licenses, you can just export for it. Now, obviously, there are going to be bugs specific to that platform, and it's not just a plug and play, but... Yeah, but you have to get into that program. Like, it's like, if your game did well enough, then they're like, well, you know, we'll help you. Like, it's a lot... It's less of a... I don't know how to even explain it. There are problems with it, as in the accessibility is lower. Which, you could argue, well, if your game didn't do super well, then what's the point of even releasing it on console? Which, like, sure, but yeah. Okay. I like this. This is plug and play. But no, I don't think... It wasn't a partnership. They just started their own studio for it. They just literally were just like, hey, we're going to port games that are made on Godot because we just kind of... There is no other option. I'm very happy that they're doing that. It means that we're going to get a lot of games that are on Godot, or made in Godot, on console. But... it is a bit of a problem in the accessibility. Wait, okay, triangulator.cs. Has to be closed source though, which is why it's a separate entity. Yeah. It's a bummer. I understand it. It would be really weird if it wasn't, actually, but... yeah. It's an inherent drawback. And some Unity ports in the past, and you don't see Godot's route as much more involved. Okay. I mean, I haven't released a console game, so I haven't done, like, any porting. But from the very little I know, it does scare me. It worries me, rather. So, I need to quickly... I'm gonna drag this stuff into my Unity project. We're doing a little bit of just flat stealing. We're actually just stealing. Unity's is pretty easy to get going, but it really just the specific console certification specs that are a real pain in the ass. Yeah, getting your game on console just seems really hard, like in general, but with Unity at least, that's something that I control. Like, how much I'm doing for that. If I don't have control over it, then that scares me. Which is honestly one of the main reasons I'm worried about going, or I'm worried about staying in Unity, because you don't really have control over a lot of different things, in the sense that they kind of just are changing things for the sake of money. Like, they did that with the whole runtime fee, and that scared everyone, and it almost killed Unity. But the example path... Okay. This should hopefully work. Okay. Fair enough. What is happening? Wait, what? What is this other object? Add vertex. Okay, wait, okay. I see what's going on here. This is weird. Very interesting. Okay, wait, let's get this into like a roughly pickaxe shape. Yeah, let's move this here, let's move this like here, and this like here. Because if we just keep track of this add vertex. Okay, we're gonna move this here, that there. Okay, it's like roughly a pickaxe shape, right? We click triangulate, and now it just triangulates. But let's say, oopsies, whoopsies. Now it's all it's all wonky. Totally still works. This might actually be the answer. We might just keep track of the points, and then move everything. Yeah. What is the license? MIT license. MIT license, my beloved. Okay. Permission is hereby granted free of charge to any person obtaining the company associated documents of the software and to deal with the software without restriction, including without limitations, right to use, copy, modify, merge, publish, distribute, sublicense, and or sell copies of the software to permit persons whom software is furnished to do so. Yeah. So that the loop doesn't cross. Yeah, no, I'm still gonna need the intersection code. Absolutely. I'm just saying, well time, I see a distinct lack of your programmer art in the show off work part of the channel, and I would really like to see it. I really do want to see your work, though. I love seeing other people's stuff. That extends to anyone! If you're lurking in chat, join the Discord. There's a link right there. This is fantastic. Someone did it for us? Oh, I'm so mad. Bro, look at this. Look. Look. Brother. Wait, no! No! No, no! Like hours of programming wasted. Is this also an MIT license? Okay, people are crazy out there giving this stuff away from free, alright? What? This is beautiful. This is actually fantastic. That's all that's in the readme. Okay, you know what? Understandable. Holy goodness.
Something 1234 redeemed to say according to ChatGPT. The process by which the Aryans may have come to dominate the Indus Valley civilization is not entirely clear, and it's a topic of ongoing debate among historians and archaeologists. However, there are
just going to be all the licenses.
Theories. Migration and settlement. The Aryans
was an MIT
nomadic
license?
pastoralists who migrated into the Indian subcontinent
Wait, this is
around
Hayes.
1500 BCE.
Wait.
It's possible that they gradually settled in the region, establishing communities and eventually
No,
gaining
this isn't.
dominance.
I thought it was Hazel. My brain. Never mind. What? At least get like a history lesson or something? What do you... Huh? Also, it's by chat. If it's a chat GPT history lesson, I feel like it's probably wrong. I'm gonna copy this, and I'm gonna put this in, like... I'm just gonna put it in a channel that I have for notes. Because I would like to give credit to anything that I use and be like, hey, this is really useful. I'm actually just gonna drop this into the, resources. Share resources. This is so awesome. What the heck? Okay. Let's go look at this one. This is basically the exact... This is literally the exact same code that we made. Like, functionally. Does it require the license? That would be really weird for an MIT license. Yeah. Because you can modify, merge, and sell copies of the software. The above copyright notice in this permission shall be included in all copies. Oh, okay. Interesting. Okay, so yes, you have to put this license in. You have to put the license? The copyright notice. The above copyright notice. Then how do you sell something? Okay, wait, how do you sell something that has an MIT license? That's not how that works. free of charge. The above copyright notice and this permission notice shall be included in all copies or subsequent portions of the software. Okay, I don't know how the heck this works. MIT license. Just don't credit? No, that's stupid. This person did fantastic work. They absolutely, without question, deserve to get credited. I just need to figure out how to do that. Okay, this script was made by Jonathan. You are freely to modify this or use yours, but please do not remove this header. Okay. I won't ever remove this header. You got it, brother. Okay. How does this work? You have to include this text next to the top of the script you copied? Okay, but he kind of did it. But he put this, and I won't remove the header. How about that? How about we come to a nice medium where he already did it for me? This is insane. How does the example use this? Vector 1, vector 2, okay. If in Unity editor. Oh, okay. This is very interesting. This is namespace haze. So I have to do using haze, right? Maybe? I think? We'll figure it out. In the end. This is very interesting, though. And then this guy... Wait. Yeah, this is literally the code that we made. Functionally. With the S and T. This is F, this is T. Like, literally. Oh, that's a clever optimization. No, wait, this isn't exactly it. This is basically it. Yeah. Very interesting, though. I think we're gonna keep with what we were doing. With the code we have. Yeah, I'm just gonna not touch this license, because he already put it there and he said don't touch it, so I will not touch it. This is triangulating the path. Okay, resets vertices to their initial position. Whoever made this, Jonathan Kings, what an absolute legend. It's so it's nicely documented. This is perfect. Okay. Set a class with utilities for triangulating triangle paths using 2D vertices. So if I go to my mesh render script, and where are you? Mesh render? Nope, I put it in mesh testing, which I should probably also put these in. Okay. Don't save. Perfect. Okay. I need to get the example path back in there, and then reset vertices, triangulate. Add vertice. Why does this not work anymore? I think you have to try it, do it once, and then there we go. Very weird. This just works though. It's makes me very happy. I'm gonna create a folder, not mine, example path, and whoa, no, not what I want. That is not what I want. Example path, and triangulator are going to go into not mine, because they are not mine. What is your problem? What? How did I... Okay. Delete? That should fix it. So weird, man. Okay, there we go. So if I go into my script, which is mine, the is mine script, and then I try to use triangulate, I can't. But if I do using haze, and then I do triangulator dot, now I have access to it. Okay, that's awesome. Now I just gotta go back, go into not mine, open these. I will add the MIT license at the top. Why not? Where is it? Just for the sake of safety. It's never gonna be a problem, and honestly, it's not even... I don't know why I'm doing it, but you know what, we're doing it, alright? Okay. MIT license. Permission is hereby granted. Okay, the above thing should be included. Whoop. There, the above thing is included. Fantastic. Anyways. Triangulator... What? Okay, so a single triangle, this is a struct. When is the triangle struct ever used? Is it used once in this code? It is. That sucks. I might have to modify some of this. Which is fine, because the triangle struct is not going to work with the current system that we have for the mesh, but add triangles to mesh. Okay. This isn't even a mesh. This isn't a mesh, but that's okay. It should be fine. So how does he use it in the example path? Okay. Very cool. And I can do something like that. And then I can triangulate and it just works. No matter where I put these, it'll just work. That's fantastic. So reset that. If in Unity editor, void reset. How is he doing this with the GUI actually? I'm very curious. Reset vertices. He gives those tooltips. Interesting. Custom editor of type example path. How did he do this? Public class example path. Okay. What? So this editor is all of the GUI stuff, I think. Okay, that's a button. GUI layout button, triangulate, undo, record object, and then that does triangulate. So weird. Okay. So this is what we actually need. The example path is the only thing that's actually implementing anything. Yeah, I don't know how to use them. So I'm missing knowledge. Or disable the warning and then restore the warning. What are you doing, friend? What happened to require that? So that's when you want to build custom tools to speed up design? Yeah, no, I know how powerful it is. That seems insane. You know what, I will. What happens? What happens? Why'd you have this? Wait, actually, no reason? Wait. Save? What if I restart Unity? Does it give an error? Because it seems like we're doing it whenever we start the editor. Interesting. I'm just gonna presume that this was a problem at one point, and cautiously, I can't put him back. It's fine. It's fine. Fine. It's fine, right? Like, yeah. Oopsies. Could have been fixed by a Unity update? That's what I'm hoping. That's gonna be our saving grace. Okay, so it creates a list of triangles. Okay. It just suppresses a warning? Yeah, that's fair. I think I'm gonna have to completely rewrite this code. I'm gonna look at it and try to figure out how it works, and then probably going to have to rewrite all of it, because he's using this triangle, and I need to use the actual mesh, so I'm gonna have to reformat this entire thing for that. I'm gonna have to ship a Theseus this bitch, and that's okay. You know? Triangulate the path. Okay. Triangulate points. What is points? Points is a list of vector 2. And then if triangle... Okay, so that just creates the triangles, right? Okay, do we have the original... We do have the original file. I'm actually just gonna do this real quick. You know, I don't need to, but... Okay, so I'm gonna use the original file as reference, and I'm gonna keep it open on my other monitor for the triangulator, and I'm going to have to kind of change it a lot, because it's using triangles, which is a struct that he created, which is fine. But... I kind of need to convert this to not work with triangles, because otherwise I'm going to have to convert the triangles, then back to triangles, basically. Okay. How do I do this? Because we have, in Unity, we have... Here's my mesh generator. We have triangles, which for each triangle is 3 vertices. I might actually be able to just use this. That may be possible. Are these vector 2s? Ah, that's gonna ruin everything. Damn it, man. Okay, we can convert it. It's fine. We can figure it out. Okay. So it triangulates it. It triangulates the points, and then it... If triangles equals null, then it creates a new list. Why would it ever... Why would it ever equal null? Why would it? How would it? What does the triangulator do that could do that? Return null. Oh. If the path source count is less than 2. Okay. That's fair. Now, what does this do besides that? Okay, so... It copies the path. Or creates a list. This is the path source. Huh. We're calling it with the points, which is not a path, but it is a list of vector 2s. So this is the points. This is the list of vector 2s. We're calling this. And we don't need the subsequent calls. Don't know what the hell that really means. Cannot triangulate path. Rotated too many times subsequently with no improvements? Okay. That scares me. Rotate path clockwise. Interesting. That's if the segment isn't valid. Okay. The first try... Interesting. Okay. Okay, we're gonna... In the not mine, this is mine, we're going to create... triangulator tester, and we're going to put this in the example script. Real quick, I'm going to add a camera so that we can see anything. This is going to be orthographic, and we're going to give it less of an ugly color. So solid color, something a little bit more like that, maybe. Cool. We're going to generate a mesh in this. Why is your sure? Okay, that shouldn't have really messed with anything, I hope. Anyways, what? I don't know what that did, to be honest, but it seems to have changed everything. So we're going to open our new script, the triangulator tester, and then we're going to try to generate a mesh. So we need triangulator tester mesh. We need to add a mesh component. a mesh filter, and a mesh render. And then the triangulator tester. I'm gonna quickly go reference my mesh testing script, save. It also needs a material. Okay. Yeah, wait, so we need to go to our materials, and we're just going to drag in mesh testing, we're going to drag in that. And now it has it. Perfect. So that's all we need. And now we need to create the mesh. So we're going to create a super simple mesh. So we're going to grab our mesh generator. Yeah. Okay. We're gonna copy this. Don't need that. Don't need that. Don't need that. Definitely need all that. Triangulate for tester. Don't need update vertex anymore. Don't need this. All we really need is set mesh and generate mesh. Don't need the update function. Don't need that. Don't need that. Don't need that. Don't need any of this. Okay, where is this being used ever? Right here. Okay, that is important. We need that. But now we're just going to put points. That may be a problem, actually. No, it won't. We'll be fine. I don't need UVs per side anymore. Okay, this can go away. Vertex width, we need that. No, we don't. We don't need vertex width anymore at all. Although we're gonna keep it just for a moment while I figure out how we're gonna do this. So this is gonna be a lot of a. This is gonna be a simpler mesh, a significantly simpler mesh. We are using haze. Good. Oh, what a horrible sound. That is my go get water alarm, so I will be back. I'm gonna go get water, I'm gonna run to the bathroom, and then we're gonna try to figure this out. I will be back in 4 minutes. Okay, starting the timer. I'm gonna put it up on the screen. Okay, I'll be right back. Okay, I'm back. We got our water. Oh, okay. So, we need to generate a mesh, but a lot different than the one we're doing. We just need a collection of points, then we need to triangulate them and then generate a mesh based on that. Alright. Okay. New triangulation script. Okay, so we need to... Let's call this 1, 2, 3... No, wait, we just need to give it a set of points, and then it'll return a set of triangles. Okay, yeah, wait, no, that works way better. Okay. So here's what we're gonna do. We don't need to generate the mesh. At all, actually. We're not gonna do this. At all. And I'm gonna keep that for reference, but actually I'll get rid of it. There's no point in having it. Like, all of this is not useful anymore. We need... Now, we just need a... array or a list? Not joint. What? Vector 2s. It's going to be points. Can I see the list? I might have to make it an array. Which if we do, that whatever. Yes. Yes, I can. Alright, good. Okay, so we're going to have this be like over there, over there. We're just gonna have like a bunch of random points. And then we're going to give those points to the triangulation script. And it's going to return a triangle, right? Yeah, look at this. Okay, we're gonna call it haze triangles. Okay, so we have haze triangles now. That's all of our triangles. Can we even see those triangles in this? I don't think we can. We can! Awesome, okay. So, we have our haze triangles, and then we're initializing that to basically be empty. And then we need to triangulate our points. And then generate a mesh. So that's adding the point, whatever, that's triangulating it. And then we just need to go through each triangle, right? These are all floats, correct? These are all vectors, so yeah, they're floats. They're vector 2s, that's fine. And now we can just do this. The triangles needs to be... So first of all, the UV needs to be the number of efforts, which is dimensions no longer holds any weight. This is just points, dot length, dot size. How big is this? Dot count capacity? I think it's count. Okay. And the triangles equals triangles times 6. Triangles.count times 6. No, times 3. Yeah. Hayes triangles.count times 3. And now we just need to go through and set all these vertices and these triangles. Setting the triangle should be really easy. Setting the UV is really easy. Because for each index, we're literally just going to set all of them to 0. The triangles is not going to be easy. Setting the UV is going to be really easy. So we're going to do a for loop here. We're going to do for each, actually, because why not? For each UV... For each vector 2? Yeah. To UV vect. In UV, we're just going to set UV vect equal to vector 2 dot 0. What? It's cannot assign UV vect for each iteration. Why? Ref. Is this it? Whatever, it doesn't matter. How about this? We just do for each int I equals 0. While I is less. While I... This needs to be 4. While I is less than UV dot length I++, and we're going to set UV index I equal to 0. So it's just going to set all of them to 0. Fine. Okay. And now we need to get this. We need to triangulate it. Triangulate all the points. Yeah, and then mesh filter dot mesh equals generate mesh. Awesome. Okay, first thing we're gonna do here is actually set Hayes triangles equal. So yeah, first we're gonna clear. No, we don't need to. We can just set it equal to triangulator dot triangulate. And then we need to give it the path, which is just the points. And now we're gonna get all these triangles. Programming, man. Okay, we're getting all these triangles. Approximately? Interesting. I wonder how exact approximately is. Doesn't matter, though. Once it's triangulated, we just need to get every point. Yeah, so here's what we're gonna do. Not uv.length. Number of verts. That is correct, yes. Oh, goodness. Okay, I don't know what this is actually going to output. Here's what we're gonna do. Because we have these points. Just how do we convert from these points to that? Okay, wait. We need to convert it to a mesh, and I'm trying to figure out how to do that, but my brain just can't wrap. I just can't figure it out. So, we're gonna add vertex. Yes. And now we triangulate this. Oh, we're hiding that in the inspector? I don't want to hide that. Wait, no. Don't hide these. I want to be able to see everything. Okay. Now, we click triangulate. Triangulate. Oops. Wait, what? Why can't that be triangulated? Okay, whatever. If 1, 2, 3, 1, 2, 3, 1, 2, 3. These connect to that triangle and that triangle. Does he have a function for just converting this to a mesh? That'd be very convenient, but I don't think there is such a thing. Because I have to, given the triangles, convert it to a mesh index. Or vertex index indices, UV indices, and triangles, which is just the UV or the vertex indices. Which is a huge problem. Okay. So, yet again, this is just the amount of points. We have point like 0 through 5, let's say. So we have 6 points. Then we could just do 0, 1, 2, 3, 4, 5 all around. And then set them to whatever that is. That would actually be fine. Yeah, so we just set this. And we set the vertices, the vertex. This doesn't need to be UTV.length. This needs to just be less than the number of verts. We're going to set vertices I equal to new vector 3 and we're just going to give it points I points I dot x point I dot y and z, which is just going to be 0. And then we need to settle the vertices based on that. Okay. We need to be able to compare these. So really, I don't need the triangles to give me back... I need the triangles to give me back the indices of the points. Is there a list.find? List dot... Yeah, so if I go like points dot find... Okay, this does exist. And then what does this return? Find element? How do I find... Okay, contains. That's a bool, whether it contains it or not. Exists, also a bool. Find index is what I need. I need to find the index. Start index. Okay. What? 0 number of vertex, or no, yeah, number of verts, and then we're gonna do vertices 0, right? Or vertices 0. Does that work? No. It needs to be predicate? What does that even mean? What is a predicate? How to find the index of an element in a list. C#. What? What does this mean? How about the list find index method? You know, that would be fantastic. What the hell is any of this talking about? Okay. Uh-huh. This is gonna be points. A dot prop? What is prop? Bar O prop something. Okay. Man. Okay. Prop O prop. What does this mean? Wait, really? Wait, this works? You can just do index of? Ah. Nice. Okay, that works. Perfect. Fantastic, even. So we're gonna do 4. We have another for loop for the triangles, and we're going to do 4 each. I know it's inefficient, don't care. Triangles. Yeah. Triangulator dot triangle. Try in Haze triangles. Then triangles. Ah. This is gonna have to be a for loop. That's okay. For int I equals 0, while I is less than triangles haze triangles that count I++, and this is going to be into I, and that's going to be haze triangles I dot A what? Oh yeah, wait. Oops. This equals vertices no, this equals points dot index of that and then we're going to do I+1. We're going to do the same thing for B. And we're going to do the same thing as we're doing here for C and I+2. I think. And now if we set the mesh, that should work. I sure hope. I suppose we're about to find out. Okay, let's try it. Okay. What if I just disable that and then play? I forgot to re-enable that. Oops. Okay. So it generated. It's just broken. Okay. 1, 2, 3, 4, 5, 6. Good, good. Minor issue. Why isn't this working? Copy. Paste. Triangulate. Okay, so it works here. That's what we should be getting in the mesh. But instead, this test mesh, okay, the normals are flipped. One big problem. That's not correct. That triangle's right. That triangle is not right. Should be 1, 2, 3, 4. That's correct. So these are all the triangles. Let's go to the triangulator mesh. These are the same. They should be the same. Haze triangles. That's correct, that's correct. Okay, that's good. So we're getting the same triangles either way. So it's something with the way that we're making the mesh. Huh. Okay, let's make this a convex shape. Triangulate that, then we're gonna copy that. We're gonna paste those points. And now see what it generates. What does it generate? Not a working mesh. Not even remotely close. No, this is correct. We went 3 times the amount of triangles. Are the vertices somehow getting mixed up? I don't think that that's likely, but let's double check it. No, that's correct. The haze triangles are correct. Yeah, they're correct. Okay. Let's make this public, I suppose. What's the worst that could happen? Don't answer that. Okay. That's pretty bad. So element 1, 2, 3. So it goes 1, 2, 3. That's right. Or wait, no, it goes 1, 2, 3. One, 2, 3. That is definitely not right. Oh wait, this is 1, 2, 3. Oops. So that's 1, 2, 3. Yeah, it's not correct. And if we look at the test mesh, that is what's happening down here. Like right here. Okay. And then it keeps getting 0. Interesting. How is that possible? It's getting the index of whatever this is. Which, when we run it, it's getting the right triangles. And this does equal this. Is it a floating point error? I find that pretty unlikely. Okay. How in the world? Why do these have to be indexes? Why does it have to make it so complicated? Okay. Getting the first vertices, or the first vector, second vector, third vector, and we're setting I plus 1 and I plus 2. So this is 0, 1, and 2. Okay. Like that so far. Then we're setting okay, wait, what? This should work. Clearly it's not, so something's very wrong. Yeah, we set 0, 1, 2, then the 3, 4, 5, and then 6, 7, 8, and then 9, 10, 11. So there are 4. 1, 2, 3, 4. That's correct. So this should be happening 4 times. Yes, it does happen 4 times. Okay. So what's the problem, man? I don't understand. Triangulate points. Okay. How does this triangulate work? How does the triangulate work? Where are you? Oh goodness. Okay. Yeah. Man, okay. I can't tell if if it's like a floating point error or something, because this should logically follow. Right? Right? It's not going super fantastic. For some reason, after element, it just always goes to 0. After it goes 1, 2, 3, 4, 5, 0. I don't know what's going on. It's very weird. I'm trying, because this works. It's triangulating it correctly. I'm just not building the mesh correctly. Here's the code I have for building the mesh. Whoop, sorry about that. Here is the generate mesh script that we have for this right now. It creates the correct amount of triangles, but they're just completely wrong. Like, the points on the triangles are wrong. And this gets the indices of the points, and it should be the exact same as the vertices. Because I just convert the vertices to the points. And then we're only looping through this as many times as there are triangles. And then we're setting the first index of the triangle set to A, then B, then C, which is the first, second, and third point of the triangle. There's something I'm not understanding about how the triangles work. Why does everyone keep linking to that? It doesn't exist. Apparently Unity used to have a triangulator, or yeah, triangulator, but it doesn't anymore? I don't know why. Wait, this is a vector 2 of points. Okay. We just, like, use this. Does it work? The square root of 6 is an irrational number, meaning it cannot be expressed as a simple fraction, and its decimal representation goes on infinitely without repeating. However, we can approximate its value to the approximation of the square root of 6. Or to find the approximation of the square root of 6, you can use numerical methods such as long division or a calculator. There's a simple method of using calculator. Turn on your calculator, press the square root button, enter 6, and press equals. Only if it were that easy. However, it's not. Written by ChatGPT. What is up with you and ChatGPT? What does this do? Inside triangle, okay. Triangulate it gives you the indices. Okay. How about you just do a list of vector 2s? Yeah, I don't understand. That just seems really weird. Okay, there we go. And now how about I just do... Okay, we're gonna have to rewrite all of this? Oh, goodness. Okay. What? Just gonna do new, or wait. Yeah, this code just doesn't work. Alright now. That's because you are a terrible person if you don't play with your dog. It's not a feeling, it's the truth. Oh, dogs are adorable. Although my cat tries to do stuff like that, and I am a horrible person, so I'm like, no. No, I'm actually in the middle of something, but thank you. I appreciate the thought. And she just stares at me, very angrily. She's like, what the heck? I thought that was just supposed to work. Okay, and I need to set triangulation. Triangulation. Equals new triangulator points. And then I need to set this to... This returns points, right? Oh, what the heck? Okay. We're just gonna do new triangulator points dot triangulate. And this should just work, I keep saying, but like, for real this time. I don't know what the license is on this, though. I don't know what this actually is, but we're gonna see if it doesn't work. We don't need this anymore. Suck. Sorry about that. Okay. My family just walks in sometimes. Thank. Okay. So this should hopefully work. We'll see. We're gonna see. You pop up with a different hoodie. That'd be really funny. Like I was just a VTuber the whole time. Just like a really realistic VTuber. It didn't work. No, it did work. But the normals are backwards. If you check the polygon is facing the opposite direction, you can change it by constructing your mesh in reverse order. Okay. Can I do triangles dot reverse? Is that a thing? Yes. Awesome. Incredible. Okay. Yeah, if I keep saying it should work, eventually it does have to. That's just the way it works, right? Like, certainly. Okay, that didn't work. It didn't reverse it. Oh, because I didn't set triangles equal to triangles not reverse, obviously. Hadoy. Dude, what is this? Okay. Um. Or. Oh, okay. Int. Indices. Indexes? indices okay, now we're going to not set triangles equal to anything, and then we're gonna do a for loop here. And it's gonna be int I. No, we need to set triangles equal to new, not number of verts, but instead indices dot length, and then we're going to do I equals 0 when I is less than indices dot length and I plus plus. Okay, we're gonna get a little bit wacky with this. Now we're gonna do. It's gonna have an int, which is going to be array length, and that's going to equal indices dot length, and then we're just gonna set everything to array length because I need to use this a lot. So we're gonna store this. So then we're going to do triangles I equals indices I, or array length minus I. I plus 1. This should work. It should have reversed it. Again, it's just if I keep saying this should work, then it'll work, right? Okay, why didn't... It did! It's just in the middle of nowhere! Oops! Wait, what? Oh. Oh. Oh, that's the problem. That's why it's not working. Wait! That's why the other one wasn't working! That... Okay, yeah. That's why the other one wasn't working too, because I'm an idiot and forgot to check if it was in the scene. I was like, well, this isn't working, so, I don't know why this isn't working. That was stupid. But this is exactly what I need, actually. I think. We're gonna see. I also need to figure out what is this? What? This is from the Unity wiki, it seems. Okay, how do I... This is like half in Spanish. I don't know what to say. How do I credit this person? Who is this person? What? This doesn't exist! Alright. Well, yoink mine now. I don't know what to do. Okay. Awesome. If I just set this to indices, would it be backwards? Let's see. Yeah, that's not right. That is right, but the camera is weird. Okay, I need to set this to -10, and then we'll be able to see it. I see it. Easy clap. There's just... I have no way of crediting this person. I don't know who this person is. Yoink. That's all I have to say, basically. I don't... Mine now. Mine? Okay. How do I see the mesh again? There we go. Because, yeah, this is fine. And then if I give it some, like, really weird... Yeah, I'm gonna add another couple points, and then we're gonna get real weird with it. Something like this. We're gonna copy this, and we're gonna paste it. Yeah, no, it just works. Well, shucks. Kinda don't know what else to say. I mean, it's not the same mesh. But I'm gonna guess that this is probably a lot more efficient. Because it's not dealing, or I don't have to, like, convert it back. Okay, well, I guess we're going to go to the not mine folder, and then make it a mine folder. I'm deleting example path? Actually, we're not going to delete that. We're going to delete example path entirely because we don't need it anymore. And then we're just going to copy. You know, okay, I kept saying this should work, and it did work. So, like... Just saying. It worked. I was right. It worked eventually. Okay. Oops. I'm just gonna, like... Go up there, yoink that. But what is the problem? Oh yeah, I can get rid of this. Awesome. Okay. There has to be a way to reverse this easily, right? No, we'll just keep it this way. It's fine. It works fine. And now we just need to basically pump this in. We just need the generate mesh. And then we go to our mesh renderer. That doesn't exist anymore. I mean, this doesn't even really need to be a model behavior. We don't need to attach this to anything. It's just kind of plug and go. Plug and play. This really doesn't need to be public. This can be private. That can be private. This can be private. I can't believe that this just... You know, it just works. What can you say? It's just really funny. Okay, we're gonna create a mesh. I'm actually just gonna go dump this into the triangulate folder. We don't need points anymore. This just needs to take in a list of vector2's called points. Although, why don't we just set that? Why don't we just make that a vector3? Because, yeah, no, that way I can just do... Yeah, we're just gonna do points. I. And then we're just going to cast this. Do I want to cast this, or instead just have this be a vector3? Would that even be a problem? This literally only triangulates. Well, also gets the area. Is area used anywhere here? Yeah, it is. These are all private. This is the only public. When is endpoints used? Okay, okay. So I definitely do need to create a new triangulator each time. Or... I'm gonna be updating it every time anyway. Yeah, I don't really need this constructor. I just need to, whenever I do triangulate, I need to have points. This needs to take in a list, a vector 3 points. And then that should be fine. No, it doesn't take a... It takes a vector 2 now. Okay, wait. No, I need to get rid of this. We're just going to set m points equal to points. Is that gonna cause any errors? No. Okay. Alright! This is jank! Oh boy! Triangulator does not exist. What is your problem? Ugh. Okay. What? An object reference is acquired for a non-static field. Method. What? Okay, maybe I'll just not mess with this, actually. Maybe it's not worth my time. And then I'm gonna have to redo all of this. Yep. Okay, we're gonna set this to a vector 2. And now all is right in the world. Good. Good, 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 good. Probably not a bad idea to have a reference to all these things. So then we have a reference to all of these, and if we really need them, we can just get them. So we can have like a getter and setter for each of these, but I'm gonna just grab this and then drop it in here. And triangulator can be private now. Not triangulator. Triangulate can be private. And now all we ever need to do is yeah, let's do that. And then we're just going to do triangulate. It really would be easier if I just... When I call this, m_points equals points. And then just never have that. Because it quite frankly seems silly to use it. Start triangulator dot generate mesh. Why can't I do that? It's because it's not mono behavior? Is that really the reason? Why can't I get generate mesh? What? I don't understand. Have class. Okay. Yep, we just have to keep that. Ugh, that's really annoying. I'm just gonna have to rename... Well, I can't. M underscore... M underscore... What's even the point of it being M underscore? Let's just rename this. 2 points. Okay, points equals underscore points. Perfect. Now I can just completely delete the triangulator tester, because I don't need it anymore. Oh yeah, we're not using that. And then... Triangulator tester is just gone. And then we're going to drag the triangulator into mesh testing. And then delete not mine. Because it is now completely mine. Yoink. Alright, where are you? It's mine? Yoink? Now, this isn't even the triangulator. This is just the mesh. This just creates the mesh. So we're actually going to rename all of this entirely. We're going to rename including comments, including strings. Yes. Okay, this is gonna be mesh generator. Okay, and now we need to completely rewrite the script. Woo! Real happy about that one. Man. Okay. I kinda don't even want to touch this script. We can just delete that scene. Okay. We don't need the line cross checker either. That's completely redundant and not needed. I don't need that. We'll keep that. Keep that. I don't even think we really need the event system, but we'll keep it, because I don't know what happens when you don't have it. No, I think we do need it. For UI. We don't need it right now. We'll keep it, though. Mesh testing object is needed. Main camera is definitely needed. Click indicator. We need that. Alright. We have the mesh generator, the mesh testing UI, and mesh testing. We're in an interesting spot. To where we do not... I don't want to delete this code, so we might just create another script. And triangulator doesn't exist. I know this code doesn't work. I know it doesn't. But I want to keep it. So we're going to rename this to old mesh testing. Now we're going to create a new mesh testing script. And then basically just copy everything in here. Although we can't really use most things in here. Because we're generating the mesh differently now. So now we just need a bunch of points. Yeah, okay. So we're going to... When are we using this again? We're just gonna copy all this. Open new mesh testing. Nope, that's the UI. Open the new mesh testing. Yoink. That's the mesh generator. Oops. Okay, we're gonna scroll down, yoink all of our old code. We're gonna try to transfer it to the new system, if you can even call it that. Pixels per unit. Don't need it. Hammer force, damping factor, those are pretty important. Last height, last width, don't need that anymore. We don't need any of the fixed update. UVs per tile side, don't need that. We're gonna get rid of this. We don't need anything in the generate mesh script anymore. At all. And we don't need this, that. No, wait, we might need that. We might need all of that, actually. No, we don't. We need these two. We don't need anything in that. Get vertex by offset. When is this used? The update vertex. We're gonna have to kind of gut update vertex. Kind of entirely, actually. This we need. Up until... Yeah, number of verts. So we need to find the number of verts immediately. The hammer force and damping force, that's still staying. This needs to be triangulate. You're lurking? Welcome. We are... I have a GIF. I have a GIF to show you. Because currently the code does not work. Because I broke it. Here is what we had. So we had... Whenever we would click, it would move the mesh around. There were some bugs. Namely that it didn't work very well when we got too convex. Which is a huge problem, as we want to make kind of any shape that we would want. So now we're completely rewriting the system to instead, based on the outside points, create a coherent mesh, and we're going to recreate the mesh every time the player clicks. Actually, we don't need to do it every time the player clicks. We can just do it every time there's an intersection. We're figuring it out. But yeah, that's for the anvil minigame. So the player has to, like, move that mesh towards, like, oh, in a pickaxe shape, or a sword shape, or an axe shape. We're gonna figure out how we determine how close it is to one of those. Not right now. That is a future me problem. Okay. Yeah, I literally cannot use that anymore. I can't use this update vertex anymore either. Goodness, okay. We're just gonna have to completely rewrite this. Yeah. Man. Yeah, we're gonna have to completely rewrite that. Okay, and then for mesh generation, we're going to need to generate the mesh. So, checking lines for intersection, this is awesome. I think the mesh generator also does this actually, inside triangle. No, it doesn't. Kind of does. This is more complicated, though. Yeah, we need to create a new mesh generator and then generate the mesh. Could also be able to reset the points, but I'm actually gonna make that a thing. We're gonna have public void set points, and that's going to be... It's literally just gonna do this. But instead it's going to be a void and called set points. And then we actually do not need this constructor ever, because we're just going to do set points. Awesome. So first, we need to get the points. We need to create the points. Or really populate a list of points. Then we need to generate mesh based on points. Actually, I'm gonna set a thing right here that's if... Yeah, we really don't ever want to use this. It's not gonna error, no. Okay. If points dot empty. No, dot... Is there an empty? Is that a thing? How do I check if this is empty? You can just reverse it like that? I can't just return a list. I can. Okay, and then we just do equals triangulate dot reverse dot to array. What? Okay. List indices equals triangulate indices dot reverse, and now this equals indices. Awesome. Oh, that's how you actually spell indices. Oops. Yeah, I can get rid of this, this, indices, indices, dot to array. If points dot count. I need to check if it's initialized. Um, does this just work? Okay. If points does not equal null, that should be okay. I hope. If it does equal null, then we're just going to error. Or really, we just return. I'm just gonna cause problems. Very good. Okay, so that will just error. Although I'm gonna know. It's gonna error anyway. Whatever. Okay, so I need to first get all of the outside points. Then generate the mesh based on that on those points, and then re-implement hammer movement. Or hammer mechanic. Mechanic? Yes. I can't spell today. I don't know what's going on. What is the problem with this? Oh. I just have to, yeah, okay. Mesh, generator, there just has to be constructor. That's fine. I need to give it a list. Which I currently don't have one, so we're just gonna let that error. Don't need this to be public, really. Actually, probably wouldn't be bad to have it public, just so we can make sure that everything's working right. Number of vertices is just going to be... It's gonna be the width times the height. We're gonna have an off by 1 problem. Let's say the width is 4. We're gonna have 1, 2, 3, 4. Say the height is also 4. 1, 2, 3, 4. Then we only want... Yeah, 1, 2. So it's going to be width times 2. No. It's going to be width minus 2 times 2 plus height times 2 minus 2 plus 4. Because that would give us, here, that would give us 2, so that'd be 4 plus 4 plus 4, which is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's right. Okay. I'm happy with that. Vertex width doesn't need to exist. No, it does not. Okay, and then in set mesh, we're just going to, where are you? Set the number of vertices, or number of verts, equal to 2 times width minus 2 plus 2. I could just do this times 2. It's going to be height minus 2, which this is really just width plus height minus 4 plus 4 at the end to account for that. Yes. And that is the number of verts we need. Now we need to populate the vertices points, which we're going to rename this 2 points. And then That takes in a list. We can just make this a list. And this takes in a vector 2. Okay. No, wait. Let's convert all of these to vector 2. No, I don't want that. We don't want to do that, actually. Okay. We're just gonna actually comment that out. Just so I remember to fix it later. Velocity is now a vector 2. Vertex velocities was always a vector 2. That's fine. Are there any other errors? Nope, we're good. So now we have a list of points, so we can put that in there. But first we need to create our mesh. So for int I plus the number of verts. Actually, would we even need to do this? Couldn't we just have like, wait, what if we just set this to width? No, wait. Oops. No, it definitely needs to be number of verts. That needs to be equal to 0. While I is less than number of verts, I++. Okay. And now we just need to go 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 1, 2. So first, we need to go over the number of the width. So yeah, we need the... Why is this a list? Why is points a list, though? Does this really need to be a list? Dot count? No, this doesn't need to be a list. There's actually no point for it. Okay. Then we're actually just going to have a vector 2. Yeah. This is also going to be a vector 2. And now we're just going to, instead of doing count, we're just going to do length. Which is the exact same thing. Okay. That should fix that. So now, instead, we're just going to have, instead of a list, we're going to have a vector2 array. And we're going to set points. Yep, perfect. Now we just, again, need to go around. So it's going to be... First, we need to go over the amount of width. So it's going to be 1, 2, 3, 4. There has to be an algorithm for this. Alright. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 1, 2. So we need to go over 1, over 1, over 1. And we need to start going up at a certain point. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my goodness, please. 8, 9, 10, 11, 12. In this hypothetical scenario. So this is 0. Yeah, 0 mod 3 is 0? Or 0, sorry? 6 mod 3 is 0. 3 mod 3 is 0. Correct? Yes. So if the index is 0, then we know that's going to be mod 0. 6 is mod 0. All of these are mod 0. At the end, it's mod 0. This is when it cuts off, so we don't need to worry about that. But we need to turn whenever it's mod 0. So we can have a variable. Whoop. That's like the direction that we're going, or the addition vector, we'll call it. Yeah. So the first time we turn, so we can have an int, and that's like turns. It's gonna equal 0. And then if turn, we can just have a switch, and when turns equals 1, when turns equals 0, which it does by default, then we're going to add the vector um 1, 0 to our current position. Plus position. And then when we're at 1, 2, 3. This is going to be 0, 1 plus position. And then this is going to be -1, 0 plus position. And then this is going to be 0, -1. Plus position. So... Ooh, that's a problem. Because we need the int turns. We also need the turns, and then to write that out, basically. We also need our position. Vector to position. Yeah, that equals vector 2.0. So I'm just going to make that equal to transform.position. Now we're going to do if we need our position, and then also vector to current move. We're just going to call it move direction. That's going to equal vector 2.right initially. We're going to check if I modulo the width equals 0. If it doesn't, then we're going to check if I modulo the height equals 0. Wait, so I need to check if turns modulo 2 equals 0, and then I need to yes. Because if it's even, then we want to do the width, which is going to be, whoop, where are you? Even, odd, even, odd. Then we want to check if turns. There's a much more elegant way to do this probably, but if turns equals 0, then move there equals vector 2.up. Else if turns equals 2, then vector 2, or move there equals vector 2 dot down. One. Then we want to go left. I can just do this actually. Okay. So this way, this should work, I think. Yeah. trying to think through this. So if we're 0, so let's say that width is 4 and height is 2. Let's say height is 5, sure. So this is 0. Good. So we move on to the next. Nope. Well, 0 with 0, so I need to have another one if I does not equal 0. Now we're gonna do points. I equals position. Actually, no, we're gonna do position plus equals move there. Okay. I don't know how this is gonna break, but we're gonna find out. Okay, we're gonna give the new mesh testing script to this object. We're gonna remove that. Okay. So not quite remotely correct. Oh yeah, okay, that makes sense. So what is the mesh looking like? Huh. We have 14 points. There's clearly some overlap. Okay, so we have 0, 1, 2, 3, 4, 5. That's correct. 5, 1, 2, 3, 4, 1, 2, 3. Okay. That's the problem. I think. Wait, where are we? Where's the set? Set mesh, okay. We're not turning down again. Like, if we look at this, it's not going down. It goes up. Or it goes left or right. It goes up. And then it goes left. And then it does not go down. So we're turning. Why are we not ever going down? Let's print turns. Yeah, that works for me. Oh, wait. What? Oh, that's the problem. Because it gets down here, and then it's like, nah, we're good. So it goes over 5. It starts at 0, 1, 2, 3, 4, 5. Then it goes up 1, 2, 3. It only goes up 3. 1, 2, 3, 4, 5. That's right. 1, 2, 3. That's correct. Then it goes to the left. 1, 2. That's not right. But then it gets to element 10 and it breaks. Huh. Okay. So it goes over 1, 2, 3. That's good. Or 1, 2, 3. Okay, perfect. Actually, not perfect. Because that's going over more than it should. That's creating 1, 2, 3, 4 vertices. That's the problem. This algorithm just doesn't work. Shucks. Okay, so this is length 4? So it's 4 by 4. What if we change this up? It was like 4 by 5. This is 4, this is 6, 7, 8, 9, 10, 11, 12, 13. And there are 14 in total. Which 5, it's 5 plus 4, so it's 9, 5, 10, 14. That's right. Okay. So we have the correct number of vertices. That's the start, and then we need to figure out the correct number of everything else. The correct number of turns, how we're gonna get there. So this is 4. This is 5. What's the width and the height? So with a width of 4 and a height of 5, 14 vertices in total. After 4, we need to go up 1. So when I is equal to 3, or really to 4, then we need to start moving up. Or wait, at 3 we need to start moving up. When it is 7, when I equals 7, we need to start moving left. When I equals 10, we need to start moving down. Okay. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. It's gonna be 1, 2. Okay. 1, 2, 3, 4. So first we need to move over the entire width. I'm gonna do something really silly. I'm just gonna have a bunch of different for loops because I want to get this to work, and then we'll do it later. Basically. Okay, when I is less than width, then position. Yes, and then. We're going to set points I to position. Okay, we're actually going to set... Yeah, that works. And then we're going to have another for loop. It's going to be height. This time we need to move up. We moved over the entire width. My 4 hours is over. I must end. I'm gonna try to finish this like in a really jank way, and then I will end. But thank you, Alex. 1, 2, 3, 4. So I'll finish this upstream. Anyways, thank you guys very much for watching. I'm gonna be. We're gonna see. I think I might change my stream schedule. I don't know. Everything's kind of up in the air. There's a good chance I'm going to be back Thursday. If I'm not, then I will send an announcement in the Discord. But thank you very much for watching. I appreciate all your guys' time and also the help that you guys give me. Alright, have a fantastic night.